आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सॉल्यूशन पाओ। डाउनलोड नाउ।
Let's discuss the given problem. In the given problem, we have been given a function fx, that is a function of x, and it says that fx is equivalent to x log cos x upon log cos of 1 plus x square when x is non-zero, and when x is 0, fx is equals to 0. So we have to actually comment on the continuity of the given function, right? So first of all, let us solve the value of this function at x equal to 0, that we have to check the limit of this function at x equal to 0, right? So first of all, we know that limit of this function when x tends to 0 is equal to what? It is equal to 0. That is given in the problem, right? Now let us evaluate the value of left hand limit. So that would be limit of x tending to 0 minus f of x, right? And this time it would be equal to limit of x tending to 0 minus, and this is x, this is log cos x divided by, this is log of 1 plus x square, right? Now to solve such kind of problem, first of all we need to substitute the value of x equal to 0 in this equation. So this would be limit x tending to 0 minus, right? Now when we substitute the value of x as 0, this is 0 multiplied by log cos 0 is again 1, so this is log 1 divided by log of 1 plus 0 is 1, and we know that log 1 is 0, so this becomes something like 0 by 0 format. Now to solve such kind of problem, we need to apply L'Hopital rule, right? Why? Because we have gained an expression which is of format 0 by 0. So basically L'Hopital is applied where we have a function of format limit x tending to a constant, let us say k, and such that f of x divided by g of x is equal to limit of x tending to k, and this becomes f dash x divided by g dash x. Why? Because the value of f of x is equals to g of x is equals to 0 when x is equals to k, right? So this becomes the condition when we apply L'Hopital to any expression. So this is the same condition which we are facing here. So we need to just differentiate the numerator part and the denominator part separately, right? So we are going to apply L'Hopital simultaneously to the numerator and denominator. So this would be limit x tending to 0 minus. Now we need to differentiate x log cos x, right? So we know that this would be actually done with the help of product rule. According to product rule, we have to differentiate one by one, right? So first of all, differentiating x, so this would be log cos x, because differentiation of x is 1, and then this time the differentiation of log cos x, so this is x, and differentiation of log cos x would be, this is 1 upon cos x, and differentiation cos x would be minus of sin x, right? So now we have differentiated the numerator part. Now we have to differentiate the denominator part. So differentiation of log of 1 plus x square would be 1 upon 1 plus x square, and then differentiating 1 plus x square, that gives us 2x, right? So this becomes the differentiation of this one, and now we need to substitute the value of x as 0. So this becomes limit x tending to 0 minus, and this is log cos 0. Now we know that cos 0 is what? Cos 0 is 1, so this would be log of 1 plus, this is x, that is 0. Something multiplied and divided by 0 is obviously 0, so we need not solve it again further. Now this is 2x, again 0, and this is divided by 1 plus 0, so that is 1. So 0 divided by 1 is again 0. So actually we obtain a expression of again format 0 by 0. So we have to just differentiate this again, because this is again 0 by 0, so we have to apply L'Hopital to this expression, right? Now when we apply L'Hopital to this one, that is we have to differentiate the numerator part. So we have to differentiate log cos x, and the differentiation of log cos x is 1 upon cos x multiplied by minus of sin x, right? Similarly we have to differentiate this one also. So this is basically x, this is minus x tan x, right? So we can just write it down here that the value of this is minus of x tan x, right? Now we can differentiate this, so this would be minus of 10x, and this would be minus of x, and then the differentiation of 10x is sec square x, right? And now differentiating the denominator part. So in the denominator we have 2x upon 1 plus x square, right? 2x upon 1 plus x square. So for this we need division rule. So for this, first of all, we are going to differentiate the numerator. So that is 2 multiplied by 1 plus x square minus differentiation of denominator part, that is 2x multiplied by numerator 2x, and then divided by square of denominator, that gives us 1 plus x square whole square, right? So this becomes the differentiation. Now we have to solve this expression further. So first of all, substituting the value of x as 0 in this equation, so this would give us, this would become 0, this would also become 0, and this would be minus x sec square x, that is again 0, because 0 multiplied by something is always 0. Now this is divided by 2 into 1 plus x square minus 2 into 0. So this is basically 2 into 1 plus 0, that is 2, minus 2 into 0 is 0, divided by 1 plus 0 is again 1. So this becomes 0 by 2, and this is 0. So we can say that the value of limit x tending to 0 minus becomes equal to 0. Similarly, we are going to solve for the expression when the limit is tending to 0 plus, right? So when x is tending to 0 plus, the value of f of x would be equal to what? Again the same function, that is equal to x log cos x upon log 1 plus x square. So this is x log cos x upon 1 plus, this is inside log of 1 plus x square, right? Again when x is tending to 0 plus, so we are going to solve this problem similarly as we have solved this like method. So after following this method, we'll get the same expression, that is 0 1, right? So we can conclude that the value of this function, the value of f of x at x equals to 0 is what? It is equals to 0, right? And when x is tending to 0 plus, it is also equal to 0. When x is tending to 0 minus, at that time also it is 0. So we can say that the given function is continuous, right? So the function is continuous at x equal to 0.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।